Many applications require finding a local minimum or maximum of a function, and the derivative is very useful for that. So let's look at a function here, y equals f of x. We see that at the local minimum, the slope of the tangent line becomes 0 at the minimum, and also at a local maximum, the slope of the tangent line also becomes 0. So we define what's called the critical points of a function. So the critical points are the values of x where f prime of x, let's call those values x equals x star, is equal to 0. So the places where the derivative of the function are 0 are called critical points. And if the function has a local minimum or a local maximum, those will occur at critical points. So if we have a critical point of a function, then how do we know whether it's a local minimum or a local maximum? So let's first look at the local minimum. So what happens near the critical point? Well, so f, the derivative here, f prime of x, when x is less than the critical point, the slope is down, so the derivative of the function is negative. So f prime of x is less than 0 when x is smaller than the critical point. On the other hand, if x is larger than the critical point, then the function is moving upwards and the slope is positive. So f prime of x is greater than 0 if x is greater than the critical point. Okay, and what can we say about the second derivative? So here the first derivative is negative, 0, and then positive. So the first derivative is an increasing function. If the first derivative is an increasing function, then the second derivative is positive. So here at the critical point, the second derivative of the function at the critical point has to be positive. So the second derivative is positive then at a local minimum. What about a local maximum? Everything should be reversed now. So f prime of x is what? So we look here that if x is less than x star, the slope is upwards. So f prime of x is positive, so greater than 0 if x is less than x star. And then if x is greater than x star, the slope is negative, sloping downward. So it's f prime of x is less than 0 if x is greater than x star. Finally, what can we say about the second derivative at the critical point? Well, we have a first derivative is positive, then 0, and then negative. So the first derivative is decreasing function of x. So that means the second derivative is negative. So f double prime of x star is less than 0. So if you have a critical point where f prime of x is equal to 0, we have what's called a first derivative test. You can test the value of the first derivative on both sides of the critical point to determine if it's a local minimum or a local maximum. Or we have something called a second derivative test. So if you can easily take the second derivative of the function, if it's the second derivative at the critical point is positive, then it's a local minimum. And if the second derivative of the function at the critical point is negative, then it's a local maximum. There's one more feature of a graph that's worth explaining. We can have a graph that looks something like this one, this type of shape. This part of the graph down here is called concave up. The derivative is increasing, so the second derivative here is positive. So f double prime of x is greater than 0. This part of the graph is called concave down. The derivative here then is it's steep here, but then it's becoming less steep as we go up. So the slope is decreasing, and that means then the second derivative here is negative. So there's a special point here, which is the transition from concave up to concave down, somewhere over here. And exactly at that point, the second derivative is 0. And that point is called an inflection point. So sometimes that's useful when you're graphing a function to know where the inflection points are. Okay, let me summarize. So the derivative will be a very useful tool to determine local maximum and minimum. To do that, we take the derivative of the function and set it equal to 0. If we solve this equation, then we solve for the critical points, and those points may be local minimum and local maximum, provided that they satisfy either the first derivative test here or what we call the second derivative test. I'm Jeff Chasnoff. Thanks for watching, and I'll see you in the next video.